Bauxite is a very interesting deposit. So interesting is it that there exists a relative silence, if you will, on new ideas surrounding the genesis of bauxite. Now, in this discussion, I want you to take this that the parameters on which I have placed or created this video reside in the project that I was a part of. And this project is the brainchild of Clarendon Copper Minerals. Among the objectives of this project is to find out whether or not the origin of bauxite can be outside of the general status quo. Note this description in terms of bauxite's genesis from Google AI. Bauxite forms from the intense long-term weathering of aluminum-rich rocks such as igneous or sedimentary rocks in hot, humid climates. It goes on to highlight some of the key processes for bauxite formation, including the residual accumulation of the bauxite as a result of leaching of minerals such as silica related minerals. Mention is also made of bauxite's formation in depressions within karst environments. So in essence, bauxite in terms of its formation and its residual deposition is on the surface. This project changes this narrative. We conducted fieldwork on this project in the period of August 2025 to October 2025. This image that we can see here is a mined out pit. What I want you to specifically pay attention to are those lenticular zones. And these zones are of interest because of the reality that what we have found in our study area is the consistency of these lenticular bodies throughout the study area. Our study area encompassed the region of Clarendon, Harmons, through Manchester, Mandeville Highway, specifically, Spurtree, Nain, all the way to Treasure Beach. Now, as mentioned, this lenticular body here is on the highway. We then now see in this image whereby these lenticular bodies exist. And this is specifically along the road within Nain, St. Elizabeth. Note the bauxite material that is within these lenticular bodies. Is it not interesting to see that the bauxite has this kind of a shape? This image would have been taken closer to the Hatfield in Manchester region. And again, this is a lenticular body where we can see bauxite deposition. Yet, no mention is made in literature on the potential or even on these kind of bodies to be specific. Now, where it is that we are here in this video is on Treasure Beach. And why it is important for you to actually see this video is because, for one, I have here images of black sand. When we see black sand, obviously it brings us to iron. And when we also see black sand, it brings us to igneous origin. But I am taken, or led rather, by our partner here, who is from Clarendon Copper Minerals. And he brings to my attention these circular vents. And why this is of significance is because what it is we theorize in this project is that these vents are basically the transport bodies, if you will, for the bauxite material. So just as how I would have shown you the images of the lenticular bodies in Manchester, which is at a higher elevation, let's just say 600 meters above sea level relative to where we are now, which is at sea level. We are looking at the origins, basically, of these lenticular bodies. Now, what it is that you should also grasp is that in terms of these lenticular bodies, they have surrounding them these fossils. And it is key to mention this because basically what I want you to gather is that these lenticular bodies are not young per se. It's not just recent that these were formed. But yet still that is also very interesting to note that even though these bodies here have a degree of pristine preservation of their circular nature, they do not appear to seem as if to say they are rugged or there is any form of interference. And that is a good question that needs to be asked. How is that possible? This image or this video here, I'm basically resting or beside two fault zones. And the key thing is that those fault zones are in tandem with where we see these vents. Coming back to these images, what it is that I'm basically showing you here is a close-up in terms of how the bauxite residue looks. And if you look very carefully and closely, you must can see that it is apparent that there is flow, indicating that the bauxite could have basically been somewhat like a slurry, a molten slurry, a hot slurry. And this then now is as a result left this kind of a impression. How is it that this kind of an impression could exist if it's a case that bauxite could have only been formed on the surface? I want you to note that what we did is measure the circumference of the vents. And the circumference of the vents at Treasure Beach has similar size to those vents we would have measured at locations that included the Nain region as well as up in Hatfield. So that basically is a question that has to be, raised, which is, could it be that these circular impressions were once, fully lenticular, like one long hollow region that basically would have become shifted as a result of tectonic forces, such as the fault that I would have highlighted earlier. Look at this image, a karst outcrop with what appears to be bauxitic material sandwiched in the middle. This would have been at the Georges Plain era in St. Elizabeth. A closer up, you suppose you can see what appears to be, again, a representation of bauxite material that would have flown out like a slurry again from being in between this karst outcrop. Here is a video representation of same. Now again, if bauxite is formed on the surface as the majority of the literature expresses, why is it that we're seeing this representation in the field? Another question has to be asked, that why is it bauxite is heavily being said in Jamaica's case to have formed as a result of carbonate breakdown, yet still the chemistry of carbonate relative to bauxite is not the same. I go a step further. How is it then that we are saying that we have rare earth elements present in bauxite, and yet still, as regards to the parent rock is being touted as being that of white limestone group, or at worst case, yellow limestone group? These questions and their answers are what it is that this project has sought to settle. What it is that I can share here and what you can see is that in terms of Jamaica's bauxite formation, it is not resting on being formed superficially on the surface. There is evidence that exists, as I have shown in this video, that bauxite's formation has a genesis proof from within the earth, from these circular vents, or as Mr. Wood would have indicated, pipes. In terms of now what it is that this research went on to try and prove is whether or not there is hydrothermal source as in regards to how these bauxites could have formed. And if that's the case, what makes this very interesting is that in Jamaica's context, as regards to precious metals, hydrothermal sources is a key source. So, if hydrothermal sources are a key source for Jamaica's copper and gold, as I have presented it in other videos, so you know that we're saying that hydrothermal source may be the key behind Jamaica's bauxite genesis, gives us another question to ask, which could be that could it be that, like how bauxite is a source of rare earth elements, a bauxite could also be a source for placer deposits, as an example, for minerals such as copper and gold. A lot of commendation is given to Mr. Wood and Clarendon Copper Minerals for pioneering, for him taking his thoughts and basically raising questions and even being bold enough to challenge the status quo within the science of bauxite. It is my intention with this video to basically let it be known that this is basically where this project has actually started, or the grounds on which this project would have been formed, and more than likely what the findings of this project should provide. If you would like to get these findings, reach out to Clarendon Copper Minerals, especially as regards to the geochemical analysis and etc. It is indeed a good work that has been done.